Hey, Emily, so this is just the video solution for this if you want kind of a step-by-step walkthrough of this. So we're asked determine values of M&M for this function, f of x, such that it gives a remainder of 0 if it's divided by both 2x plus 1 and 4x minus 1. And one of the key things that's in this question is that we have this and term in here. So it's including both of those when we're considering the solution. It's not one or the other. It has to be divisible by both of those at the same time. And depending on how your teacher taught you, I'm not sure how she's or they have made a comparison to factors or to dividing polynomials or anything like that. But it's useful to consider the just the basic multiplication of or finding the area of a box. So what I'm going to do, I'm just going to write out what these factors are here, or what these two things that we need to take into account when we're solving this. So we have 2x plus 1 is going to be, and I'm going to call it a. I'm going to say a is going to equal 2x plus 1. And I'm going to say that b is equal to our other condition here of 4x minus 1. And what this is asking is it's saying if we take this function of f of x, I'm not going to write out the full thing, I'm just going to write out as f of x. And if we divide this by a and b, or in other words, if we take this function of f of x and if we divide it by a multiplied by b, or a b, like they both have to be there, this is the whole condition of this, we should get some number that has a remainder of 0. Has a remainder of 0. And if we're thinking about remainders, we're asking ourselves, we have this box here, and this box represents f of x. It represents this big function up here, okay? And what we're asked is we need to figure out what values of m and n for this function are true in order to make it so that both of these are factors of this. Because what we can think about in terms of factor, well, let's get a and b out of the denominator here. And to do that, well, we can multiply a and b out, right? We can say a, b, multiply that out of here, and then we have to do that over here, a, b. And then we can say that f of x, where this function up here, is also equal, or it's equivalent to, whatever number we're supposed to get out of it that has a remainder of 0 times a and b, times a and b. Or in other words, if we also represent this function as an area, well, then we can represent that area by multiplying two sides, right? We have two sides to every box to find its area. So essentially, what one of those sides is going to have to be, one of them has to be a 2x plus 1, and the other one has to be a 4x minus 1 in order for this to have a perfect area with no remaining pieces or cutoff parts. And just as a quick refresher, a remainder is anything that's kind of left over if we try and divide this in the exact same amount of sections. So here I'm trying to divide our vertical columns into groups of 2, and we see that we can't do that, right? Because you can do it, but you have this remainder at the end. Not all of it divides equally into 2. But we can do that. We can do this if we divide into 3s, right? If we do it into 3s, then we get a perfect group of 3 in each section here with no remainder left over. And this is the thing that we're going to leverage in order to help solve this, because if we're having no remainder left over, that means that 2x plus 1 has to be a perfect side length for this area that we're finding, and 4x minus 1 also has to be another perfect side length for the area that we're finding. So what does this mean? How can we actually use this as useful information to solve this? Well, let's just consider our first, let's consider a here. A, which is equal to 2x plus 1. Well, let's figure out what x would be for this small polynomial here. I'm sure that your teachers taught you how to solve for x in this case, and it's also equivalent to finding the root or finding the zeros of a function if he's talked about that. And what we're going to do, we're just going to set this function equal to 0, and we're going to solve for x. So we do this, we get 2x equals -1, 2x is -1 over 2. And we can do this for b as well. So b, what did we say b was? 4x minus 1. And what do we get? We get 4x minus 1 equals 0. 4x equals 1, 4, 4, and we get x is also equal to 1 over 4. So you can kind of think of these as side lengths. They're not exactly the same thing as side lengths, but they work for our case in order to get this polynomial, or this overall function that gives us an answer that has an answer of a flat answer of some number with no remainder at all, or with no decimal trailing on it at all. Okay. So how can we use these two? Well, we know if we're going to assume that both of these multiply together to give us our final function, we know that if we plug them into our original function, we can get two equations out of it. And then we're going to use those two equations together to help us solve for what m and n are equal to. So let's plug in for case A, let's plug in x equals -1/2, and we'll plug in that for f of x up here. So let's do case A, x equals -1/2, okay? So we got f of -1/2. This equals, okay, so we have m -1/2 power 4 plus n -1/2 to power 3, 68 -1/2 squared minus -1/2. It's a plus 6, minus 6. So you can go ahead, plug this all into a calculator to solve this as fast as possible. We'll see if I can get through this mildly quick. So I'm not wasting your time. So this will be m, oops. Just make sure that this is, yeah, okay. So we got m over 2 times 2 is 4 times 8 is 16 plus n over, oops, sorry, that's gonna be a minus. N over 8, this is gonna be 68 divided by 4, 17. It's gonna be a plus 1/2. And then minus 6. This is m over 16 minus n over 8. 17 minus 6 is 11 plus 1/2 is 11.5 plus 11.5. And then what I'm going to do here, I'm just going to multiply everything here by 16 so that we don't have any fractions. So we'll do times 16. So we got m minus 2n and 11.5 times 16. What does that give us? 184. And what I'm going to do, I'm just going to label this kind of its own equation here. So let's make it pink. We'll say this is equation 1. Okay, so there's case A. Let's do case B as quick as possible here. Case B, which is, what do we say x was in case B? 1 over 4. So we're just going to plug in again for our function here, f of 1 over 4. And what's that going to look like? So we have m. This one's going to be a bit more annoying. 4 plus n, 1 over 4, 3 plus 68, 1 over 4, 2 minus 1 over 4 minus 6. 4 to the power of 4, 4 times 4 times 4 times 4, 256. Oops. That's m over 256 plus n over 4 times 4 times 4, 64 plus 68 divided by 4. I think that's divisible. Or sorry, 68 divided by 16. It's not really. Whatever. We'll just do that. We'll just say it's 4.25 minus 1 over 4. Let's just make that decimal point as well. Minus 0.25 minus 6. So 4.25 minus 0.25, that's 4. 4 minus 6 is -2. Minus 2. Let's multiply everything here by 256 just to get rid of those fractions. And we get, let's write this in a new color. Let's do it in blue. 256 divided by 64 is 4. So we have m plus 4n. 256 divided times 2, 512 minus 512. This is equation 2. Okay, so what we've essentially done here, we've plugged in our two different cases of x. We've plugged in our two different cases of x. So we have two equations. Let's write both of them out here. So we had in our pink one, we had m minus 2n plus 184. And we have m plus 4n minus 512. And what we're going to say, technically they're all equal to 0. They're all equal to 0, right? Because again, when we're finding these, when we're using these as a means to solve for our equation, when we plug in these values for our equation, we're finding the zeros, we're finding the point at which this function equals 0 at those points, okay? So both of these have to equal 0. And what's nice is we have two equations now. We have two equations, and we have two unknowns that we don't know. And what we can do, we can utilize these two equations to help us solve for one of the unknowns. And the way that we're going to do this is by subtracting. We're going to use subtraction. So I'm just going to erase those numbers there. We're going to subtract these two equations though. And the way I'm going to do this first, is I'm going to set them up a little bit differently, which means, oops, the lights just went off in the room. Let's wave them back on. Okay. I'm just going to rearrange it so that I have the constants or these numbers right here on the other side of the equation. So we're going to have m minus 2n equals negative 184. I did write that down right. Yep. And over here we have m plus 4n equals 512. Okay. We have two equations, they're both different, but what we're trying to find is when they both equal one another. This is just another form of writing, if you remember, y equals mx plus b. If you remember writing just linear equations, this is another form of writing a linear equation, okay? And we need to find where those two linear equations are going to intersect each other. Because at the point where these two intersect, that's where their m and n values are equal. And it's going to help us answer this question as to when both of these will give us a remainder of 0 for this question. So what I'm going to do, I'm going to subtract these. I'm going to treat this just as like a regular subtraction problem like that you've seen in like grade 1 and stuff. So 42, 31, just stacking everything, and then we're just going to subtract through, right? So here we have m minus m, which is just 0. So we have 0m. Negative 2n minus 4n, well, that's just negative 6n, equals, and then negative 184 minus 512. 184 minus, 112, that gives us 696, negative 696. So we're left with negative 6n equals negative 696. We can isolate n by dividing by 6, and we get n equals, what is that, divided by 6? 116, positive 116. Okay. And now that we have this, well, we can plug this into either into 1 or 2. Plug into 1 or 2 for our equations here. So remember, this was called equation 1 here. This was called equation 2. Doesn't matter which one you plug, and then you can solve for. M, as in Mary. Okay, so I'm just going to plug in equation 1. It doesn't matter. Both of them are kind of nice and simple. So we have m minus 2 times 116 plus 184 equals 0. Okay, and m to 116, that's going to be 232 minus 232 plus 184 equals 0. 232, let's just do 184 minus 232, it's negative 48. And m equals positive 48. So there's our two values of m and n. M is, and you can double check this if you want by just plugging in for either of these, for case A or for case B. It's, well, you actually have to do for both of them if you want to check both of them. We just plug in those two numbers that we found for m and n. And if you get a function that's equal to 0 with both of them, then you're off to the races. You're perfectly good. Okay, so that's it. I don't know, you can finish it off with just like, therefore, the function has m equal 48 and n equal to 116 for it to have 2x plus 1 and 4x minus 1, 2x plus 1 and 4x minus 1, divisible with a remainder of 0. So there's that. I hope that wasn't too confusing, and I hope it didn't go too fast there. Yeah, if you have any questions, just shoot me a message there. Hope that was helpful. I'll send a PDF of this as well. That's it. Okay, see you, Emily. Nice to hear from you.